When we look at input devices, we can analyze how many different independent values they can input at the same time. This is called degrees of freedom. For example, when we have a device which a user can freely move and rotate, we have 6 degrees of freedom. Let's forget the buttons for now and look at this motion controller. I can move it in 3 different directions, that is 3 degrees. At the same time, I can rotate it around 3 different axes, that is another 3 degrees. Overall, we have 6 degrees of freedom, 6 values I can, at least in theory, adjust independent of each other. Similar 6 degrees of freedom control can be found in virtual reality headsets, which track both their position and orientation, adjusting the view accordingly. We can also look at the regular mouse. It can be moved in 2 dimensions. We have a wheel and 3 buttons. Overall, I therefore have again 6 degrees of freedom. Some of these degrees are a bit different than in the motion controller. The buttons can be only on and off instead of providing continuous value. The degrees can be binary, for example a button which can only be on or off. They can be discrete, meaning the values adjust in steps. The mouse wheel is like this. They can also be continuous, such as my mouse or motion controller movement. This type is often called analog. The discrete and continuous movement can be unbound, that is, I can scroll indefinitely using the mouse wheel, or bound to some limits, for example game controllers' analog sticks. Another parameter in an input is whether it is isotonic, elastic or isometric. Isotonic input means free, continuous movement. This move controller is isotonic. The movement has no hard boundaries. An example of elastic input is an analog stick on a gaming controller. I can move it, but only within some limits. Finally, isometric input means that there is no movement in the input. Most common cases of such input today are touchscreens and touchpads. These devices do not move when touched. Still, isometric input can be continuous or analog. This means that the force applied is measured. In summary, if we look at this gamepad, we have 2 analog knobs, that is 4 degrees of freedom with elastic continuous input. There are in total 9 digital buttons, plus the knobs can be clicked, that is 11 degrees of freedom with digital elastic input. Then we have 2 analog triggers, that's 2 degrees of freedom continuous elastic input. And a D-pad, that is 2 degrees of discrete elastic input. Theoretically, this gives us 19 degrees of freedom controller, but since you cannot operate all the inputs at the same time, perhaps 8 degrees of freedom is what can be realized at one time.